class with our algebra tiles, we saw our little investigation with completing the square, and hopefully having that visual of what are we actually needing to physically complete that square with our algebra tiles helped solidify your knowledge of this if you have seen completing the square before. But just kind of as a recap, we saw this example in class where I gave you x squared plus 6x, and I asked you how many of those little tiny cubes do you need to complete your square? And you got that it was 9. So just kind of remember, and you should have this in your notes from class also, that in order to complete that square, we have to add b divided by 2 squared. Okay? And then we could always write this as, because after we complete the square, it's a perfect square trinomial we have here. We can write this as our factor, x plus b divided by 2, all squared. Okay, so I guess just kind of as another quick example, with completing the square, if I asked you to complete the square for x squared minus 10x, I'm really asking you, okay, what number has to go here? Okay, to find out what number has to go here in order to make this a perfect square trinomial, I take my b value, which is negative 10, divided by 2, which would be negative 5, and square it, positive 25. And then to write this as a perfect square binomial, binomial meaning I have two terms squared, I would have x minus, well, x plus b divided by 2, but b divided by 2 would be negative 5. So x minus 5 squared. All right, so that's completing the square again in a nutshell. Now let's use completing the square to solve our quadratic equations. This is going to be example 4a in section 4.6. Solving quadratics by completing the square. And my example is to solve the equation 3x squared plus 18x minus 3 equals 0. And I hope you noticed right away that I have an a value of 3. And that is a problem. Okay? So right here, I see my a value is 3. A must be 1 to complete the square. There are other methods for completing the square than what we are doing, but we'll just kind of stick with, if we are going to complete the square, our a value has to be 1. So we have to divide both sides of our equation by 3 before we even get started. And that gives us x squared plus 6x minus 1 equals 0. Now this looks a little bit different from what we did up here, because up here, I just left this as a blank. We had to figure out what number would have to go here to give us a perfect square trinomial. In my problem, I have a number here, but this is definitely not a perfect square trinomial. All right, in order to figure out how I'm going to complete the square, I'm just going to cover up this number right here. And I'm going to ask you, if this was a perfect square trinomial, like what I see up here, what would this number have to be? And you might notice, well, it has to be 9 because it's the same thing, x squared plus 6x. But just kind of get in the habit of thinking, in order to complete my square, I have to take b divided by 2 and square it. b is 6, divided by 2 is 3, square it is 9. I need this number to be a 9. So how am I going to get there? I have -1 right now. To get from -1 to 9, I have to add 10. And I can do that as long as I add 10 to both sides in my equation. That gives me x squared plus 6x plus 9 equals 10. I can do that to one side as long as we add to the other as well. Okay, now this x squared plus 6x plus 9, we can write as our perfect square trinomial, x plus 3 squared. And then solve like what we were doing before. I can take the square root of both sides. And don't forget, as soon as we take that square root, the plus or minus goes in there. Square root of 10 doesn't simplify. It's not a whole number, so I'll leave it as that. Subtract 3 from both sides, and I get my solution. X equals -3 plus or minus the square root of 10.